Hi, in this video we are looking at bearing application questions again. This time we're looking at a slight variation on the previous one. So we've got a question here. Jamie and Jazz leave their house in different directions. Jamie walks 5 kilometers at a true bearing of 80 degrees. Jazz walks 8.5 kilometers at a true bearing of 240 degrees. Determine how far Jamie is from Jazz and in what direction. So again, a lot of information. Let's draw a diagram and figure it out. So again, we've got a small set of axes here. We've got Jamie is 5 kilometers, true bearing of 80. So about there. We've got Jazz walking from the same location, 8.5 kilometers at a true bearing of 240. So we got 90, 80, 270. So we're somewhere down here. And this vector is a bit longer. So we've got, this is where Jazz ends up. This is where Jamie ends up. Let's put our angles in. That's 80. That's 5 kilometers. This one is 240. Let's change the color. That angle there, 240. And 8.5 kilometers. Okay. Now, what does the question ask? Determine how far Jamie is from Jazz. So if we draw a vector, how far Jamie is from is the keyword, so it's from Jazz. So it's going from Jazz to Jamie. So we are looking at this vector here, from Jazz to Jamie, and we are looking at the magnitude of that vector. We are also looking at the angle. If we write on here, and it's really nice to do this at the start because it helps break the whole problem down. If we call this vector A, vector B, and vector C, we want our position vector going from Jazz to Jamie. So that's going to be going in this direction here, which is C equals negative A plus B. So this is the vector addition we need to do to work out this position vector up here. So now the components are largely the same as our previous example. We've just got a slightly different setup because this time we're subtracting the vectors. So if we have a look at vector A and we want to write this in component form, we've got, let's draw this axis up here again. We've got a vector coming out here. This is 240 degrees. We want to know what it is from the positive x direction. So we work out this theta in here. Theta equals 240 minus 180, which is 60 degrees. If we are working out this part, and call it theta 1, that's 180. So this is 60. This must be 30, so it's 180 plus 30, which is 210 degrees. So we've got 210 degrees for vector A. We can work out what that is now. We've got 8.5 cos 210, 8.5 sine 210. So that's our A vector. Again, there's a lot of little intricacies in this process. So if you can set it out really clearly, you're going to minimize the errors that you make. We're looking at Jamie now, so that's vector B. Let's draw our Cartesian plane or our axes here. We've got 80 here, which means if we call this theta 2, theta 2 is 90 minus 80, which is 10 degrees. So our component form, 5 cos 10, 5 sine 10. Okay, so now we need to determine our vector c. So c is negative a plus b, or b minus a. So c equals 5 cos 10 minus okay, we can work out what that is. Let's pop it in. 5 cos 10. So I get 12.28, 12.29 for my x direction. And 5.11 in my y direction. So if I'm checking my original diagram, does it travel further in the x direction and the y direction? Yes, it does. Is it going positive in both directions? It's going in the positive x, it's going in the positive y. It does. So that sort of makes sense based on what I'm looking at, which is great. Gives me a bit more confidence in my answer. We want the answer though in distance and direction. So again, we're going to work out the magnitude and direction. C 29 squared. And the square root of that. So we've got 13.31 kilometers. And our direction, we'll draw another little diagram of this. Again, I don't need my original diagram, I just need this here. So we are going 12.29 and we are going 5 up. Let's call that alpha. Inverse tan of opposite over adjacent. (22.58 degrees). That looks pretty good based on my picture. This is alpha 1, we want the true bearing. 90 minus alpha, which is 90 minus 22. And we get 67.42 degrees true, which is 67 degrees true, rounding to the nearest degree. Looking back up to determine how far Jamie is from Jazz. Okay, so Jamie is 13.31 kilometers from Jazz at a bearing. Okay, and we have our answer. So again, very similar to the previous one. The main difference is the wording of the question and that they're both starting at home from the same location and making sure that you're getting your vector in the right direction. So that keyword is from, really important to spend a lot of time in the initial stages setting your diagram up, because once you've set it up, once you have your targeted vector addition equation, it allows you to focus on the little step-by-step parts of the process rather than having a lot of stuff going on in your brain at the same time. I hope you enjoyed the video, and I'll see you for the next one. This video accompanies a worksheet series that aims to develop conceptual understanding with vectors. If you'd like to access the worksheet, click in the description below.